Alright, for today's lesson we're going to work on solving systems of equations graphically. So we're first going to review just what systems of equations are, and then we're going to go back to our skills with graphing equations. So that's why we just finished that test on the graphing. So, if you are given two or more equations, this is called a system of equations. The solution to a system of equation consists of all the sets of ordered pairs x, y that satisfy or make true all of the equations in the system. So in today's lesson we're going to investigate ways of finding the solution for two linear equations. The first method of solving systems of equations is using graphs. So we're going to look at this example here. So it says consider the system of linear equations, and again remember system of equations just means more than one equation, so I've got two equations shown below. The graphs of both linear functions are shown on the grid to the right. So these are the graphs of each of these. Let me use highlighters to label each one. Y equals x plus 2. That means the y-intercept is at 2 and the slope is positive, so it's got to be this one. And the second one, y equals negative x minus 4, is my other equation. The y-intercept is negative 4 and the slope is negative. So it asks us to list the y-intercepts of each equation as a point. So the y-intercept in the blue equation is 0, 2. And the second y-intercept is 0, negative 4. So just reviewing some of the stuff we learned last unit, just being able to identify the y-intercepts in our equations. Then we're going to complete a table of values for each equations, and I'll let you use a graphing calculator for this. So let me grab my graphing calculator and we'll try plugging these in. Alright, so the first equation is y equals negative x minus 4. So let me slide this up. So I'm going to go to y equals. If anything's in your calculator, just clear it out by hitting the clear key. The first equation is y equals negative x minus 4. To get the table, I hit second and graph. And now I can fill in my values. So this one starts at negative 5, so I'm just going to start my table at negative 5 and write down the values. So it's negative 5, 1, 0, negative 1, negative 2, negative 3. Do the same steps. Y equals, clear it out. I'm going to type in my second equation. And then hit second graph for the second equation. So that's at negative 3, negative 2, negative 1, 0, and 1. So looking at your tables, is there a spot that have, or two coordinates that are the same in each table? So looking at it, at negative 5 I get 1, here not the same. These two are not the same. But if you look at negative 3 at negative 1, there is a common point. So for my solution here, the value that's the same is negative 3, negative 1. And if you look back at the graph, that's where the two lines were intersecting. So if we slide back up here to the graph, for the two equations, they were intersecting at that coordinate, negative 3, negative 1. So to solve a system of equations by graphing, you can graph both lines and see where they intersect. That's all you're looking for. And really, all that really takes is either graphing the line or looking at the tables and seeing what coordinates they have in common. So each solution for these two equations is negative 3, negative 1. Okay, so let's try some more examples. Exercise 2. Solve the following system of linear equations by graphing using the slope and the y-intercept method, and then check your solutions. So the first one, y equals negative 2x plus 5. I know my y-intercept is 5, so I put a dot at 5. And then I use my slope to get the next point. So remember, this could be rewritten as negative 2 over 1. So I'm going down 2 and 1 to the right. And the slope means you just keep using it. So I go down 2 again and 1 to the right. Down 2 again and 1 to the right. That's what the whole point of the slope is, because it tells you the direction of your graph. I want you to at least get 2 or 3 points to make a line, because it'll help you get the direction of your line. So that's the first line. The second line, I'm going to use a different colored pen. Here the y-intercept is 2, and the slope is up 1 over 1, up 1 over 1. So I can draw my graph. So at what point do the graphs intersect? So you're looking at where they're crossing, and it looks like they're crossing at 1, 3. And you can check that if you plug in 1 into each equation, -2 times 1 is -2, plus 5 is 3, and 1 plus 2 is 3. So each one gives me the same solution, so we're good. You can also use your calculator again to complete the table of values. So I'm going to hit y equals, clear out that equation, and type in the new equation. Second graph, and fill in my values. Notice this table starts at 0, so I'm moving my table to start at 0. So it starts at 2, and then it's going up 1. For the second equation, same thing, clear it out, type in the equation, and fill in your values. That's starting at 5 and then going down 2. And then you can tell right by looking at the tables that here's the point of solution that they each have in common, which is what we said from the graph. So either method works. Also, if you wanted to, you could type both equations in at the same time, just using the y1 and the y2, and then hit second table, and it gives you, this is the first equation, this is the second equation. You're just looking for where there's a match, so it might be easier to see here, because right there you can see the match at 3. Okay, let's do one more example together, and then let you try the rest on your own. In exercise 3, it's asking, which of the following is a solution to the systems of equations consisting of this equation and this equation? Since you don't have a graph, you might have to use your calculator on this one. So I'm going to clear out the screen and just type in my two equations. My first one will be 4x plus 11, and then -x plus 1. So I just typed in each one. This is y1, and I made this one y2. Hit second table, or second graph, and now we can compare. So the first one says when x is 0, do you get 11 for both equations? So you do get 11 for the first one, but you don't get it for the second one. So that's a wrong answer. Then when x is -2, do you get 3 for both? And it looks like you do. So there's your answer. Check the other two though, just to make sure. When you plug in 3, one of the equations gives you -2, but not both. And when you plug in 2, this isn't even a right answer. So it's got to be the third choice. Alright, the last problem here. Use your graphing calculator to set up an XY chart for the following two linear functions. Then solve the system of linear equations. So the issue currently with these two equations is that they're not in the y equals mx plus b form. So that's why we spent some time last week practicing rewriting equations in y equals mx plus b. So I'm going to do that for each one. Here's 5x minus y equals 13, and y plus 7x equals 11. To get y by itself and no negative, I have to subtract 5x. So I get -y equals -5x plus 13. I'm just writing down these terms. These are not like terms, you can't add them. And then I divide by -1 from everything, because there's a negative in front of that y. So y equals 5x minus 13. This equation is a little bit easier. To get y by itself, I just have to subtract 7x. So y equals negative 7x plus 11. So now that I have it in those forms, I can put it into my calculator and see where they match up. So I'll clear out these ones. Here I have negative 7x plus 11 and 5x minus 13. It's second graph, and now I'm looking for the same value when I plug them in. So when x goes in as negative 3, nope, I don't get the same value. Nothing here. Looks close, but one's negative, one's positive. Still not the same. Right here. When x is 2, both equations give me negative 3. So there's my solution. 2, negative 3. And just to prove this to you, plug it in. If I plug in 2 for x into this equation, and I solve, I get y equals negative 7 times 2, which is negative 14, plus 11. So it gives you y equals negative 3. In this equation, when you plug in 2, 5 times 2 minus 13, 10 minus 13, y equals negative 3. So solving systems of equations by graphing, you're looking for where the two graphs are intersecting at the same point. So they should each have the same point that they go through. Try the graphing practice problems now.